Alright, let's take a look at the last part of yesterday's notes that we didn't get a chance, or the notes before the weekend. Let's finish those off. We had one last thing left to do. So at the end of our notes from previous lesson, we had the rate of change that we hadn't gotten a chance to finish. So let's finish that off. I've already filled these in for you, so you just gotta copy them down. I'll kind of walk you through them. So first things first, rate of change can be found from a graph by finding the change in the dependent variable and dividing it by the change in the independent variable. So as a formula, what does that mean? It means change in y values divided by the change in x values. So I'll give you a moment to copy that down. Then we'll take a look at our first example. Alright, so our first example is right here. A water tank on a farm near Swift Current, Saskatchewan holds 6,000 liters. Graph A represents the tank being filled at a constant rate. Graph B represents the tank being emptied at a constant rate. So if you take a look at this graph, I'm going to pick any 2 points I want. And first things first, I'll identify what the independent variable is, which is time. I'll identify what the dependent variable is, which is volume in this case, the y values. And we have to find the rate of change. So here's how we're going to go about finding the rate of change. Here are the steps that I'm going to follow. I'm going to choose 2 points on the graph. I'm going to calculate the change in y values and the change in the x values of the points. I'm going to take a look at that ratio. Change in y values divided by change in x values. So once again, choose 2 points on the graph, calculate the change in y values and the change in x values of the points, and we're going to take a look at the ratio of those changes. So on the first graph, if you take a look at it, we want to pick 2 points. So the ones I picked are 120, 6,000 and 80, 4,000. If I take a look at the change in y values, you'll notice that the volume, which is the change in y values, goes up by 2,000 and the time is increased by 40 minutes. So the change in y values is increased by 2,000 liters. Change in x values as time goes up by 40 minutes. As a result, the rate of change for that expression would be change in y values is 2,000, so 2,000 liters, divided by change in x values is 40 minutes, so divided by 40 minutes. The rate of change factor we have is 40 liters per minute. Sorry, 50 liters per minute. Similarly, we can do the same thing with the next item or the next graph. If you take a look at graph B on the other hand again is a graph of a tank being emptied at a constant rate. So this time we want to take a look at the change in y values versus change in x values. This time if you take a look at it, you'll notice that the y values, well, the point I'm going to pick is 20, 4,000 and the second point I'm going to pick is 40, 2,000. So change in x values or change in y values is going to be represented by looking at the x and y values of those points. So in this case, going from point 1 to point 2, my volume drops by 2,000, yet the time still increases by 20. So what I say is a volume is getting dropped by 2,000, so negative 2,000. Time is increasing by 20 minutes. If I go from this point to that point, I'm increasing by 20 minutes, from 20 to 40, and then volume is going from 4,000 to 2,000, so down by 2,000. So when I take a look at the rate of change here, I get that the rate of change is going to be negative 2,000 liters divided by 20 minutes. As a result, that's negative 100 liters per minute. So that's the rate of change for the second graph. What the negative means here, the negative just means that you're losing water at the rate of 100 liters per minute, whereas on the other example here on this side we had a positive 50 liters per minute. That just meant that we are filling in the tank at the rate of 50 liters per minute. So our next problem part is which rate is faster. Even though the 50 is positive, right, and the 100 is negative, if you compare how fast or how slow something is filling up, you're filling something up at the rate of 50 liters per minute, you're emptying it at the rate of 100 liters per minute. So the one that's got a higher or a faster rate is the 100 liters per minute emptying. That's a faster rate of change. Even though it's a negative number, it means it's emptying faster than the 50. So we kind of ignore the negative sign here. We just look at which number is bigger. That's a higher rate of change.